In lesson 4.14, we're going to continue looking at absolute value functions, and we're going to get a little more into the details of how these functions work. So in our first example, 14.1, we are given another list of guesses. This time, guesses about what is the average temperature of Toronto in February 2017. So average temperature. And now down here, they tell us the actual average temperature was 0 degrees Celsius. So using that, we can see how far off were these people when they made their guesses. In other words, what was their absolute guessing error? So I've set up a table here. Let's run through this. If they had guessed 5, that means that they were 5 degrees off from 0. If they guessed 2, well, then they were 2 degrees off from 0. Remember, like we talked about last time, if they guessed -5, they were also still 5 degrees off from 0. Because this is an absolute error, we don't have negative numbers as our errors. So I'm going to finish filling in the rest of this table, and I'll be right back. I finished filling in the table. You can check out the numbers up there. Our next step is to use these values to go ahead and graph this guess versus absolute error plot. So we can go ahead and start plotting points. If the guess was 5, then the absolute error was also 5, so that point is right here. If the guess was 2, the absolute error was also 2, so that point is right there. If the guess was -5, the absolute error was 5, which is right there. And you can kind of see where this is going, so I'll finish filling this in. So there are all of our points plotted, and I'll zoom in a little bit here. One thing I want to point out is this makes that V-shaped graph that we saw in our last lesson, where there is this point down here at the bottom, and it goes up and to the right and up and to the left from there. This point on the graph actually has a name. That is called the vertex, which you may have heard that term before when you're talking about like triangles, for example, calling the corners the vertex. So this point on our absolute value graphs is also called a vertex. Now, the next part asks us to try to write a rule for this function. So one thing we could write here is that you take their guess x, and if it's negative, make it positive. That's essentially what we did in this problem, right? All of our guesses, if it was 5, the output was still 5. If it was 2, the output was still 2. If it was -5 as the input, then we made it +5 as the output, because -5 is 5 away from 0. Another way to think about this rule is you can find how far from 0 the guess x is. That's another way to think about this rule that we're doing here. Or, and this is where we're going to get into some of the details of this, to write an absolute value function, we actually have a notation for this. We can write y equals the absolute value of x. Now that's what these lines right here mean. These two lines mean the absolute value. And you may have seen this before, but we're just bringing it up again in case you haven't. Now this function can also be written as a piecewise function. Specifically, we can write y equals, well, if x is greater than or equal to 0, then our output is just the same as our input. It's x. If x is less than 0, in other words, if it's negative, then we take the opposite of it. We make it positive. So our output will be -x. So there are a few ways we can talk about this rule, and also a couple different ways to write the rule for an absolute value function.